Okay, so I finished the renovation of the shed. Now actually it's a bit posh to be called a shed anymore. I think I've done quite a good job, so I'm gonna start calling it the studio. Anyway, we're here in the studio and we've got our cables coming through the wall from the solar system that we're putting in. And of course what we need to do now is add the switchgear and the control electronics so we can actually get what comes in and our batteries to put something out so we can light lights and run sockets, that kind of thing. Now to do that, I tend to be a little bit anal about some things, and arranging electronics is one of those things that I do tend to be a little bit conservative about. So what we're going to do, in order to keep it organised and so that I can experiment with it easily later, is we're going to put it on a board. I mean, I could just screw it to the wall, but I'm actually going to put it onto this board here. In order to make that board stand off, I've got some door stops. So these are the old-fashioned door stops that are 1 inch high, or 24mm, and 30mm across. And when I put them on the back of here, they're actually going to make really good standoffs. So we need to put this onto the wall where it covers over these cables and create holes in this so the cables can come through the board. So let's do that. You might have noticed that I did tag these before I started doing that. I put a bit of tape around them so I could tell which one was which, because of course I've split the board into System A and System B. System A is going to be all our DC stuff and System B is going to be all our AC stuff. And as I said, experimentation, but I tagged them. You have to remember to tag stuff or you'll never remember which way around it is without doing an awful lot of work to try and find it. So just put a couple of tags on the ends of your wire. Okay, so we've got everything sorted out. Now then, what we need to do is basically isolate everything. So I've got these, which is a couple of miniature circuit breakers, and they go to the solar cells. So the solar cells have a DC MCB. This particular one is 6 kiloamps at 1000 volts. So very much overkill, hey, for what we want. But that's going to go on there, and the solar panels will come into here, and then they'll come out of here, and then they'll go into the solar charge controller. So there'll be one there for System A and one there for System B. So let's put those in. Right, now we've got our solar panel isolators on, we need a battery isolator, and that's what this will do. This is rated at anywhere between 12 and 48 volts and about 400 amps. So it's going to do the job fine, and we're isolating the positive. So we need to put a lug on here, then that will bolt on there like that, and our out will come from here with another lug, and we just screw it to the board, and again 2 of them to isolate the batteries. So that's the switchgear finished. So now we can isolate the solar panels, we can isolate the battery. All we've really got to do is terminate this, the negative, and you might notice there's a bolt right there. Again, there's loads of ways you can do this. We could put in a negative bus bar if we wanted, but that bolt will just perform the same function. We pop a lug on there, attach the negative to that. Then we can attach all of the negatives to here that we need to attach, and of course we have our negative return. When I've done that, what I'll do is I'll trim this off, and when I trim that off I'll 3D print a cap that goes on it so it's nicely capped off. But we need to terminate the negative, and we need to give negative a way to connect to other things. A bolt, a bus bar works just as well. So now let's put a lug on this and bolt it down. And there they are in place. Now then, we've finished with that switch gear, we're ready for the control gear, which is basically this. As I said, this is a PWM solar controller. We discussed that much earlier in a much earlier video. An MPPT controller will be exactly the same placement. All we do is screw it to the board, and then of course we've got a list of connections here, and it tells you what they are. There's the load, there's the solar panels, and there's batteries, and there's a little symbol above the plus and the minus. So we screw it on there like that, and then we just connect up these wires. Okay, and that's it all fixed down. Now it's really nothing more than crimping on these spade terminals, sliding them in there, and tightening down the screwdrivers. It's ready to go. Of course, we've got System A and System B because we're going to do one at DC and one at AC. With DC, there's actually not much more, in fact, nothing really to do with it. There's a little output here called load, and you can connect straight to that if you want, but it's not tremendously advisable. I mean, this would be, I guess, fine for one application, but of course we've got lights outside, lights inside, probably going to put some phone chargers. There's a LED driven cure station that's DC that I want to run off of it. So there's a few circuits that I want to be able to run from system A, and I'm not quite sure what else to do with it. So I've got this. This is a fuse board. It's a fuse board meant for caravans, buses, cars, boats. So it's up to 48 volts. There are 12 circuits. The little LEDs light up to tell you it's working. It's got a plus and a minus. That goes slap bang there. Then from our load here, we take the plus, load here, we take the minus, and we take the minus to here and the plus to there. Then we've got a distribution board that we can distribute our DC circuits from, where that is the negative and the positive goes in here, and of course your fuse goes in there. So for the DC, we need to fit that. Now, for the AC, what we need is an inverter. So here we've got the straightforward stuff. Very often you find the controllers and the inverters in one box, which is awesome until one bit goes wrong, of course, when you have to pay to have the whole thing refurbished or throw it away and buy a new one. All we've done is split the controller from the inverter, and I'm using 2 bits of equipment to do the job, and this is a 150 watt inverter. The reason it's a 150 watt inverter is that I don't really intend on doing much on AC here anyway, with a maximum load of about 60 watts for the 3D printer. So you normally find your inverter sitting right there. So we've got for the DC a fuse block, for the AC a straightforward inverter that we can just plug into. But I have had a little bit of a change of heart, and we'll talk about that in a minute. Let's get the fuse board on first. Okay, so there is the fuse board on, and here it's going to the load from the actual controller to the negative, and then the positive to the positive load on the controller. There's one circuit which is my outside lights, and we did that in a previous video, how I used a buck boost converter to change the 12 volts to the volts needed, but it joins on the neutral here, and then of course it's on that side of the live with a fuse in there, so it's all fused up and ready to go. Snap the cover on. We want to add circuits. We've got up to 12 circuits, and each circuit can max out at 30 amps, so a reasonable size fuse board. Now, although my system is built a certain way for I want it, the logic here is always the same. Your solar panels come in via an isolator. Your battery comes in via an isolator. You'll have some kind of charge controller and some kind maybe of inverter, and then some kind of distribution board. This distribution board, in my case it's fuses, but it's distributing the power from here around where you want to use it. That is the fundamental of any solar setup, and in fact a wind setup looks very similar as well. Now, as I say, I've had a change of heart about this bit, and we're going to talk about that in a second, but having 2 identical systems like this means that I can actually leave one alone and change the other, and of course compare the 2. So that's a big thing for me. It may not be for you, in which case yours is going to look just like that. So here is my change of heart. The only AC bit of equipment I want to use out here at the moment is this thing here. It's the Halot X1 that was sent to me, and it's 60 watts. This cost me £25, and I can think of it like a reverse power brick, if you like. And with a lot of things that are DC, for example this one here, which is the curing station, it comes with this, and that changes AC to DC. This changes DC to AC. So I was thinking, well, why not just keep the whole thing DC? And at the point that I want to use it, use something like this, which is pretty much cheap actually, and just stick it there and then have the whole thing DC. So that's what I'm probably going to do, and of course I've ordered a new fuse board to do exactly that and keep those 2 systems actually identical, and then I can test one against the other. Right, that's it, so ready to go. Now, of course, I've left this exposed so you can see it, but it does need a protective cover around it, like some kind of cabinet maybe. But batteries on first, and my solar power controller starts, and then we flip on the solar panels, and it'll start charging the battery, and the lights that we attached are going to be able to be turned on. And Ta-da! Now they may not be showing up too well because we've got quite a bright day, but there's the lights on, and it might seem like a lot of trouble to go to for fairy lights at the bottom of the garden, and to be honest, it is. If you wanted something like this, there's much simpler ways of doing it, but I wanted to do something that was a full install in miniature with my ability to be able to experiment later as we add in things like alternative batteries and wind power. But I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.